Welcome back to Denver.
Yeah, really, for sure. I had a very quick trip to Florida,
Yeah.
but everything is good. I met my new granddaughter. She's beautiful and healthy and happy and peaceful. Oops, hold on.
Well,
There's my
that
alarm.
that's perfect.
Yeah, it is. Everything was really good. So, um, what'd you think about our last session doing specifically geometry problems instead of test questions?
It definitely, it definitely helped. Um, my biggest, I don't know what it is, but like my biggest issue is like I understand it, and then when you see another question, sometimes you're like, it takes a while to figure out, oh, what is it I need to apply here?
Hmm. Hmm. I
So,
definitely think that we should, I mean, I don't know how many sessions we're going to have, so it's a little tough for me to say, but
well, I'm planning on having a lot.
okay. Well, if we're going to have a lot, then I think we should go through lines, angles, quadrilaterals, circles, solid geometry, each of those, and then
Uh-huh.
perhaps mix it up with test questions, which will give us
Some
data
different.
sufficiencies.
Uh-huh.
We can pick back up where we left off. Last time we did test questions, it was number 13, if you remember.
Uh-huh. Yeah.
So since data sufficiencies are about 25% of the test,
Mm-hmm.
why don't we try to spend 25% of our time on data
Okay.
sufficiencies?
Yeah, that's great.
Does that sound good?
Yes.
Let's not start off with data sufficiencies because they can be a little demoralizing sometimes. That's why I don't want to. I'd hate to do a 2-hour session all on data sufficiencies. You would probably
Yeah.
feel bad, and I would feel bad
Yeah.
because I would have difficulties, and my brain would be fried also. So let's pick up. This is lines and angles. We have a few more of these questions to do, and then we'll go
Yeah.
straight to circles because we've done triangles completely.
Okay,
Hopefully you can
so
read that. Um,
well you need value of x and the ratio of y to x is 3 to 2. Right?
right.
Yeah. And okay, well there's one angle that's 90, and since the whole thing is 180,
Okay.
so you basically have 90 left.
So we know x plus y has to equal 90.
90. And then y needs to be bigger than x.
Okay. We can do this problem algebraically. Here's one equation. What's the second equation?
Y divided by x is equal to 3 divided by 2.
Exactly. And now when I have two equations and two unknowns, I can always solve it by a variety of methods. But you definitely want to be able to solve two equations and two unknowns.
And
That's
then you
more in,
solve for one. You
and
solve
then,
for one, so, and then you put it into the other.
right.
So you would
Okay.
say, for example, you need to find x. So
Okay.
you would say
If I was
y,
doing this algebraically, I would multiply the second equation by x, so I would solve for y. And then I
yeah,
would go
I
back to
just
the,
did it in the other one.
okay, it doesn't really matter, but, and then you go back and substitute for y into the
Y,
first equation and solve for x. And since
yeah,
they,
what I said before, I was like, well, it's y is equal to 90 minus x.
right.
So, but it's easier in the other one. I can see
Well, I'm
that.
not
Okay.
sure it is. There's nothing wrong with the way you did it. It's just as easy. However, there is an easier way to solve this problem
Mm-hmm.
without doing this algebra. I mean, we kind of have to do the algebra, but we do it intuitively. This is a perfect problem for what? For back solving,
Yeah.
right?
Mm-hmm.
What's the first
Well, I don't
value
know
we
what.
would check?
What? B and D.
Okay, so let's try x equals 27. What would that make y equal?
Um, yeah, I'm not really good with these ratio
Well,
things.
let's go through the back solving process because I think it's a really valuable one that you want to really get familiar with, especially with
Yeah.
problems that are better done back solving than algebraic.
Yeah, I
If
mean,
we know
I
x
got,
plus y is 90, so
yeah.
if x is 27, what would y be?
Oh, um, 43?
63.
Oh,
They
63,
have to
sorry.
add to 90. Is that a 3 to 2 relationship?
No.
Do we need to make x bigger or smaller?
I would say smaller.
If x gets smaller, y gets bigger.
Oh, it's all the other way. I mean, yeah,
Okay.
bigger.
So what's the next one we're going to try?
45.
What is y if x is 45?
That's 45.
Is that a 3 to 2 relationship?
No, so the answer must be C.
And we're done. Now,
Yeah.
once you get used to back solving, this is an easier method to solving this problem. But you kind of have to get used to the whole principle of back solving. And the principle of back solving is you pick an answer and assume it's correct. And then figure out the other values and see if they fit what we've
Yeah.
been given. That's in essence what we're doing when we're back solving.
Could you just explain? I mean, I understand ratio, but I'm always questioning, like,
Okay. It gets confusing when they give it to us like this because we have no way to put that into an equation. So let's get rid of the colon sign. That's what this is the colon sign. The colon sign can be replaced by the dividing sign.
yeah, 3 divided by 2.
Right, and y divided by x equals 3 divided by 2. So there's our equation.
Yeah. So when we had, 36 before,
Mm-hmm. The other way we could do this is we know x plus y equals 90. We know that y is, I could say y would be 3p and x would be 2p.
hmm
So 2p plus 3p equals 90, 5p equals 90, p equals 18, but since x is 2p, x has to be 36.
36. Yeah. Yeah, because, well, when then you say okay, so if x is 36 and y is 54, to make
Right,
90.
right. And
And
that's that
so,
3 to 2 relationship. So,
yeah, and so, like, I always get confused when I see those two numbers. Like, do you just say they can they can be narrowed down to 3 divided by 2?
yes,
If you, like,
they
go
are in a
from,
3 to 2 relationship.
okay.
If x was 45, they would be in a 1-to-1 relationship. If x
Oh,
was 45, then I could say this.
yeah, but
Because
it's similar because,
y would have to be 45 also. The key is knowing that x and y have to be 90.
yeah. I mean, it's definitely just, yeah, well, I'm just trying to, like, the ratio thing because I always get confused with it. So
Okay?
basically, if I took the same number and I divided it into 54 and 36, I would end up with 3 divided by 2.
Yes.
Yeah. Okay.
Okay. Let's go on, and periodically I will switch over to a test question. Interestingly enough, when I was in Florida last week, I picked up a copy of the New York Times, and they had a section about education, a whole section on
Uh-huh.
it. And I
Yeah.
read it, and I read some very interesting things, and that is that they've done studies, experiments with controlled groups, and people that learn one subject at a time do not do as well as another similar controlled group that mixes it up. In other words, if you take one subject and teach them algebra for 2 weeks and then geometry for 2 weeks and then trigonometry for 2 weeks, they do worse than the subject group that got a little bit of algebra, geometry, and trigonometry every day.
Yeah. I mean, I think it's also because like your brain gets fried. Like you have to.
You think your brain also, the learning ability is increased by changing the subject matter a little bit,
Mhm.
not staying on exactly the same subject. So there is something to be said for that. Although, personally, I think that this going through each of these geometry subjects is the best way to learn these materials. Perhaps once you've really learned the geometry or the math nicely, then it's better to go to the tests.
Mhm.
Okay, let's look at number 5 here.
What is the measure in degrees of the angle formed by the minute and hour hands of a clock at 150?
Okay. So at 150, the little hand points approximately there, and the big hand, hold on, you want to be careful about how elaborate you draw your diagrams on the test because it's very time consuming. But for these clock problems, it's important to do it at least once to draw it out. Is that an approximately good picture? In
Mhm.
other words, the little hand isn't quite the 2,
Mhm.
and the big hand is on the 10, which is 50 minutes.
Uh-huh.
So the question is, what is this angle?
Well, if you put it on a do you call it diameter?
Diameter?
A line, a line that goes through the whole circle.
Okay, like this. You want to put it through there?
Yeah.
Okay.
What do you call that in English?
Diameter?
Diameter. We call it diameter, so it's almost close.
Yeah, it's basic. Actually, I didn't draw it correct. The diameter goes from there to there. It doesn't go all the way across. Let me correct
Yeah,
that.
it's like the in the circle.
Right. It
Yeah.
connects the center point of the circle.
Yeah. Well, that line there is 180.
In fact, why don't we put 2 diameters? So now we can more easily talk about angles. How are we going to solve this problem? Can we do it all in one step? I don't see any way for us to answer what that angle is in one step.
Mm-mm.
However, we should be able to break it down. We can figure out what this angle is. We can figure out what this angle is, and we can figure out what this angle is. Let's number them. Let's talk about the easiest one. Angle 1, angle 2, and angle 3.
Why is there three angles?
Well, because the little hand is not pointed at either the 1 or the 2, but
Oh, it's
between
right in
them.
the middle. Okay.
Okay, so it's going to be
Well, the
easier
first
for
one,
us. We maybe don't need the second angle. We could probably calculate from 12 to this spot here, but I think conceptually it's going to be easier to do it in 3 pieces. What about number 1? What is the angle, first of all, between any 2 numbers? What's the angle between 12 and 1, between 1 and 2, between 2 and 3, and so forth?
30.
Correct. Because the whole thing's 360, that's 1/12. So what is angle 1 equal to?
It's 30.
60, because it's 2 of those.
Oh, you have 12 and, oh, sorry, yeah.
It's okay. It goes from 10 to 12.
12.
What's angle 2 equal to?
30.
And what's angle 3 equal to?
Well, that's a little harder, but it's because it's in between 1 and 2, so it's less than 30.
How far in between?
It's almost there.
Well, let's say the big hand was pointing towards the 6 instead of the 10. Where would the little hand be? It would be exactly halfway in between the 1 and the 2.
If it was pointing at what?
If the big hand was pointing here at the 6, like that, then we would know that the little hand was pointing halfway between the numbers 1 and 2. Well, it's not pointing at the 6, but it's pointing at the 10. So it's pointing 5/6 of the way around the circle, 10/12, which means the little hand must be 5/6 of the way from 1 to 2. So angle 3 must be 5/6 times 30 degrees. That's 25. So the sum of the 3 angles,
115.
that's the way to do it. Now, clock problems aren't terribly common. I've probably only run into 2 of them in all my years of tutoring GMAT and GRE, but it's useful to do it at least once to go through how to break it down. The key is knowing that it's 30 degrees between each number and that the percentage that the small hand is between one number and the other is the same percentage as the big hand is all the way around the clock. The big hand is 5/6 of the way around the clock. So the
5/6 away.
because
Is
it's
that 10?
right 10/12.
Oh, and then
equals
you
5/6.
you say divided by 2 is 5/6. Okay.
Right. You could use 10/12, wouldn't change anything.
Same. No, it would be the same.
Okay?
Yeah.
All right. You don't want to do too many clock problems because they're time consuming. Huh? No pun intended.
Okay. If A is equal to B, which of the following statements must be true?
Okay, so that angle there is equal to this angle here.
Uh-huh. Well, I mean, I want to say that A is right, but that's only because, but then it doesn't say that.
It doesn't say that.
Yeah.
It doesn't say that. You cannot assume it. If there is no right angle sign there, it's not, you cannot assume it's right.
Right angle. So
They-
then I
they're
would
very
say
careful
that
about
C doesn't necessarily have to be equal to D.
Well, What's the relationship between C and A? There's a word. I don't know. Do you know the word supplementary?
No.
I think that's how it's spelled. It means they add to 180.
Yeah, that's why I wanted to say that it was 90 degrees, both of them.
Angles that add to complementary. Angles that add to 90 are complementary. So those are two words that it's going to be helpful for you to know. Supplementary and complementary.
Yeah.
So
Well,
C
the
and,
first
C and A are supplementary, and B and D are supplementary also.
Well, then, yeah, I guess they have to be.
So if A is equal to B, no matter what they are, C would have to be equal to D.
Mm-hmm. Yeah, I forget that it doesn't, it doesn't necessarily need to be 90 and 90. It could be any.
Right. It can be 89 and 91 and 89 and 91.
Yeah. And it
L
says,
and K, line L and line K, are they necessarily parallel?
no. Well, your silence says that it's probably yes. But,
No, I'm thinking about it.
okay. Well, the reason why I say they don't necessarily need to be parallel is, you know, they just have to be a straight line where B and D can add up to 180. They don't necessarily need to be, parallel.
Can we draw this picture without making these two lines parallel? Let's see if I can do it. And make A and B equal to one another. Aha, I did it. There's B, there's A. Now, maybe they're not exactly equal, but I clearly can draw this second vertical line here in a manner to make B equal to A, and yet they're not parallel.
Well,
So clearly L and K are not parallel. I might have a hard time proving it, but one way to prove things is by drawing a situation where it's not true. Right.
well, great. I was right on that one.
M and N are perpendicular.
So that's when they cross, right? That's what perpendicular means.
Perpendicular means they are 90 degrees to one another. In other words, yeah, in other words, those two lines are perpendicular,
yeah.
but that line is not.
Well, I guess we would have to M and L.
In other words, if M and L are perpendicular, it means A is 90 degrees.
Well, if M and L has to be perpendicular, then wouldn't you end up in a situation where
Again, let's see if we can draw it so that it's not perpendicular. Okay, there's my first vertical line. Here's my there's my first horizontal line. There's my second horizontal line. And now I'm going to make this so that it's not perpendicular. And the only thing I need to do over here is draw it at the same angle. Ooh, hold it. A is not equal to B.
how can you see that A is not equal to B?
Well, I can see that A is an acute angle less than 90, and I can see that B is an obtuse angle greater than 90.
Yeah, because the angle like on the other side of the line is equal to A.
Well, in the premise it says A is equal to B.
Oh, I know, but
This
the
angle
way you
has
can
to
see
equal.
it, I understand what you mean. I'm just saying that the way that you can see it is that the angle on the other side is equal to A, and therefore it's not equal to B.
Okay. However, nothing dictates that this line here has to be drawn that way. Let's
Mm-hmm.
say A is like 75 degrees approximately. Well, can't I draw that line so that B is also equal to 75 degrees?
Yeah.
So I've got A equaling B, but clearly this line is not perpendicular to this line. In other words, A is not 90 degrees.
Yeah.
So M and L do not have to be perpendicular. And it's precisely the way to do these is to try to draw the diagram in a way that they're not perpendicular and yet everything is still satisfied. The premise is still
Mm-hmm.
satisfied. Oh, sorry about that. It's thundering out here, and my dog does not like thunder.
Oh, it's totally fine.
She thinks that somebody's out there making noise, and she's got to go out and bark and tell him to stop. All right. Number 7. A, B, and C. A is to B as 3 is to 5. C is to B as 2 is to 1. What is the measure of the largest angle?
Yikes, that was a lot of info.
Well, and this is a ratio problem. This is exactly what you wanted, was what to practice on.
Yeah. Okay, A to B is 3 to 5, and C to B is 2 to 1. What is the measure of the largest angle? Well, can you try and back solve it?
Perfect. I'm glad you're thinking that way. So the only problem with back solving is they're asking not for a measurement of a particular angle, but a particular largest angle. From the information they give you, can you figure out what's the largest angle?
B.
Well, what about C to B being 2 to 1? What this tells you is that C is twice the size of B.
B.
In other words, the picture they drew is not accurate.
Uh-huh.
You can't assume that it is,
Yeah.
even though they didn't label it not drawn to scale. Usually when it's drawn this poorly, they'll have a little note saying figure is not drawn to scale. But obviously they
Yeah.
didn't here.
Yeah, I've
And
seen that on the GMAT. They will say it's not drawn to scale.
right, right, and yeah, okay. But from this information here, we can tell that C has to be the largest angle.
Uh-huh.
So back solving, which one are we going to start with?
Well, I mean, since they're asking for the largest,
Uh-huh.
I'd probably start with D.
Okay, I'm not sure that... Okay, I have no problems with that. I might say start with 100, but I like where you're going. I kind of
Yeah.
prefer D now that I think about it. So,
I just always do B or D when I
okay.
back solve.
Well, you shouldn't always do B or D because some problems where they say what's the minimum or what's the maximum, sometimes it makes sense to start with the minimum or the maximum. But let's see what happens when we start with D.
Yeah.
It might be the most efficient way here. So D assumes that C
Is
is,
equal to 90.
okay. So now what are our other angles going to be?
Well, B would be 45.
What would A have to be?
40, 45.
Right. Right. Because the underlying thing we know is that A plus B plus C is equal to 180. So A would have to be 45. Does that work?
No.
Okay, because A has to be smaller than B.
B.
So B is going to have to be bigger.
Yeah, which means you need to go, the largest angle needs to be smaller.
No. It means the largest angle would have to be bigger.
Oh, yeah. sorry.
However, it's not always clear. And because it isn't always clear, I would say the safer way to do this problem is to start at 100.
Yeah.
Because you might not know whether you have to go up or down. I guess if you go the wrong direction, it will become clear very quickly that you went the wrong direction.
Uh-huh. Okay, well if C is 100, then B is 50, and then A is 30.
Does that work?
Yeah, because 30 to 60 is 35.
Right. So in a way, they were kind of rewarding the people here, I think, that started with the highest one. Maybe. I don't know. That might be my imagination. Okay. Let's see. Lines and angles. No, we didn't do these. Okay.
And they're the same on the GRE and the GMAT?
I believe they are, exactly. In fact, if you went out and bought the Kaplan GRE book and the Kaplan GMAT,
Yeah.
their algebra and geometry sections would be identical.
Yeah.
And then the GRE would have a data comparison section, and the GMAT would have a data sufficiency section that would be different. But in terms of the basic math, for both of them, I'm telling you they're question for question identical in the Kaplan series. I can't swear to any of the other publications. But so I'm fairly certain that both the GMAT and the GRE draw upon the same fundamental math formulas or principles.
Yeah. Okay. Well, this one says A, B, and C are points on a line.
So what's our first thing we're going to do?
Draw a line. And then it says B is between A and C.
So it's either like that, or don't assume necessarily that it's not like this. It merely says that B is between A and C. Okay? We'll go with the first one, but let's not forget the second possibility if it matters. Then we have M.
Okay, well then it says that let M and N be the midpoints of A and B and C.
Okay, I like that.
And AB to BC, so the piece from A to B is 3 to 1. It's like A to B, B to C is 3 to 1.
So let me redraw it like this. What is MN to BC? Again, we can use algebra, or we can do what? There's three main strategies. There's algebra, there's back solving, and then there's
substitution.
Well, picking numbers along with back solving. Or sometimes just picking numbers.
Yeah, I think the picking numbers is what they called substitution.
Oh, okay.
In the Kaplan book.
Okay.
Sorry, I'm just trying to relate it to what, you know.
No problem. No problem. So
okay.
Let's
well,
pick some numbers.
Pick some numbers.
Yeah.
Well,
give me an AB.
Well, if AB is 6.
Good.
Then BC is 2.
Good.
And then M is 3. And from A to M.
MB is 3.
3. And then BN is 1.
So MB is what?
We need to find MB.
Oh, excuse me. No, we don't. MN.
Okay, that's 4.
Excuse me. Sorry.
Yeah, that's fine. I was just like, yeah, okay.
So now
MN
what
is
is
4.
MN to BC is what?
It's 4 to 2, which is like 2 to 1.
E is the answer. So yeah, picking numbers made that real easy. And
Yeah.
you didn't necessarily, 6 was a good number to pick, better than 3, because 3 is going to involve fractions.
Yeah, I just picked 6 because I knew that half of it was between
If you
1.
can avoid fractions, you avoid them. But notice that it doesn't make a whole lot of difference. Now MN is 2, so we still have 2 to 1. So even when we use fractions, it doesn't make it that much more difficult. But I like the fact that you picked 6 and 2 as opposed to 3 and 1.
Yeah. Okay, so in the figure below, lines K and L are parallel. What is the value of y minus x?
Which is what these arrows mean, is that they're parallel.
Uh-huh. Okay, well, x plus 45 plus empty space. No. X plus 45 plus y is equal to 180.
Okay, because x plus 45, actually isn't x plus 45 equal to y based on parallel lines and transversals?
Uh-huh.
Let's look at parallel lines and transversals only. What we know here is that we create two angles, A and B, and every angle here is either A or B. This one's A, this one's B, this one's the big one, so it's A, that's A, this is B, and this is B. So this angle right there, which is x plus 45,
Uh-huh.
has to be equal to y. So I can write the equation x plus 45 equals y. So notice I only have one equation at this point.
We need another one.
No, not necessarily, because they haven't asked us to solve for x and y. They just asked us to solve for y minus x. So if I tell you that x plus 45 equals y, how would I solve for y minus x?
You would just put x on the other side of the sign.
Exactly. Subtract x from both sides of the equation, and you get y minus
So it's
x.
just 45, that's the answer.
Uh-huh. So sometimes you don't necessarily need two equations. In other words, when they ask you for something like what is y minus x, we don't actually have to solve for y and x. And in fact, I'm not sure we can solve for y and x. There's multiple values. But y minus x always has to be 45. Y could be bigger, x could be bigger, but y minus x is always a fixed quantity.
Yeah.
This is a good problem because we came across a problem similar to this where, remember, I solved it for m minus n, and you, oh no, maybe this was another student I'm thinking of, but she solved it for the individual variables m and n. And I told her that it was fine to solve for the individual variables if you can do it. But in this case, we can't do it. However, we can solve for y minus x.
Uh-huh.
Okay. Why don't every 45 minutes, let's do 15 minutes worth of data sufficiencies. Not necessarily data sufficiencies as test problems.
Test problems, yeah.
Does that sound like an idea? I'm,
No, that
I'm,
sounds great.
I'm perfectly willing to do it any way you would like, but
Oh, but this sounds fine.
it seems that it makes a certain amount of sense to.
You also have more experience in tutoring people than I do, so.
Well, these data sufficiencies, the one thing I've found is that they can be demoralizing, so you want to take them lightly, especially at first. These aren't too difficult on this particular publisher's test booklet. This is GMAT questions here. So how about 14? Well, the last one we did on this test was 13. And
Okay, so it says X, Y, and Z are non-negative integers. And then is 5 times X plus Y plus C divisible by 5.
is that divisible by 5?
Can you just
When you're considering these two statements, personally, I like handling the easier one first. You don't always have to do them in order. You don't always have to start with 1. To me, especially if time is a factor, by handling the easier one first, sometimes if you can't finish the problem and you have to go back to it, you're in a better position than you would if you tried to do the harder one first. To me, statement 2 seems like it's easier, it's simpler, it's shorter. So does that help, knowing that Z is divisible by 5?
No.
Well, what are some Z's that would be divisible by 5? Give me one.
Oh, Z's? 10?
Is that quantity that I've written right there, is that divisible by 5?
Yes.
It is. So give me another Z. 15. Is that divisible by 5?
Yes.
So as long as Z is divisible by 5, this whole thing is divisible by 5.
Yeah.
So 2 alone is a yes. Now let's go back and consider 1 alone. 1 says that this quantity is a multiple of 5.
Well, then so B is the answer, or that's what I would say if I saw this, because if that is 15, or like 10 for even that, so you say that's 50, but if C can be whatever it wants to be.
Yeah, if Z is 11, then that's not divisible by 5. If Z is 10, it would be. But without knowing anything about Z, knowing that X plus Y is divisible by 5 doesn't really help. We already have a 5 over there. So we already know that this term here is divisible by 5, no matter what X and Y is.
Yeah. So I would say that, like, B is the answer.
Right, exactly. And it is. Okay. Not a data sufficiency, but it is a geometry problem. So let's go ahead and do it.
I mean, we might as well just take them, it's like...
Okay, I agree. So its width is 5 feet, and its height is 6 feet 8 inches. You're probably not used to dealing in feet and inches, are you?
No.
Yeah, well, that's one adjustment you'll have to make.
Yeah, I mean, I will say, though, on the GMAT, there was a lot of meters, actually, in kilometers.
Yeah, that's true. There is. But that's okay. I mean, just, in other words, the answer to this does not depend on what the units are.
Yeah. What is the distance from one corner of the door to the diagonal opposite corner?
So there's D, the diagonal. So this becomes a Pythagorean theorem problem because we know this is a right angle.
So it's like
So this is 5 feet.
5.
This is 6 feet 8 inches. So how do we handle this?
So it's like 6. Can you say 6.8
No,
square?
because there are 12 inches in a foot.
Oh.
So you could say 6 point what? You could say 6.666.
Yeah.
But that's a repeating decimal, which is liable to make it difficult to figure out that. Not impossible, but more difficult.
A squared plus B squared is equal to C squared.
Right. So what's a better solution rather than converting this into feet? Let's convert everything into inches.
Okay.
Then we won't have any decimal. How many feet? How many inches is 5 feet?
You said there was 12 inches to a feet?
Uh-huh.
It's 60.
How many inches is 6 feet?
72?
Plus 8, so this side would be 80 inches. Ah, now what are we looking at?
Oh, it's a 3, 4, 5.
This has to be 100 inches. Now, what answer is 100 inches? How do we convert 100 inches into feet?
We'd have to divide it by 12.
Okay.
Um,
4 left over. 4/12 left over. So we're talking about 8 1/3 foot.
so
Which answer is 8 1/3 foot?
A.
Actually, B. 4 inches is 1/3 of a foot.
Oh, yeah, because it's 12. Okay.
And in fact, we could have just taken that as 4 inches. In other words, I didn't need to convert it to 1/3 and then back to 4 inches. I could have just said 8 feet 4 inches because of the remainder.
Uh-huh.
Okay. Well, good. I'm glad we came across that because you definitely need to know how many inches are in a foot. Apparently.
Yeah.
Now see, if this was a question in meters and centimeters, they would probably inform all of us that the relationship between centimeters and meters. You know what I'm saying?
Yeah.
It's tilted against European test takers.
Definitely is. I mean, it's like, but, for me, it's so easy because I'm like, it's a comma thing. You just move it 3 times.
Yeah.
Yeah. But I guess it's what you learn from. Okay, so that looks really tricky.
Okay. So the one thing you know it isn't is a calculator problem.
Yeah, because you don't have to calculate it out because.
Well, you wouldn't be able to do this manually. It would take you too long.
Oh.
So there must be a shortcut. That's the first assumption you want to make. Well, are there shortcuts? What's one shortcut here? What is this? In other words, if I have A times B divided by C times D, it's okay for me to look at A divided by D and multiply that by B divided by C.
Oh, it's your
The associative property applies.
Uh-huh.
So What's 9 to the 11th divided by 9 to the 9th?
1.
Subtract exponents. If you have same base, divided,
Well, that's there.
it's
That's
9 to the
2.
2. And what's this part? 11 to the 11th, or 11 to the 9th divided by 11 to the 11th.
11 to the 11 squared.
And does that go in the denominator or the numerator?
Denominator.
Right. So now we have something that we can do pretty easily. 9 squared is 81. 11 squared is 121. A. And in fact, if you didn't notice that shortcut, look at the answers and it kind of gives you clues. In other words, if I was staring at this, not sure of what to do, and I look over here and I see, wow, I see a lot of numerators and denominators that are factors of 9 and 11. This one, this one, this one, this one. So that kind of gives you a clue that there must be a way to simplify this easily.
Yeah.
Okay.
Okay, so if 3a is equal to 5b is equal to 90. Okay, so I would say 3a is equal to 90.
Okay. So A is equal to what?
30.
And B is equal to what?
Can't read it.
If you want to speed up, if you want to improve your performance on the GMAT,
You have to speed up calculating it, I know.
definitely. And that's something you can definitely do. Just get yourself some software, that flashcards or digital flashcards, and just work on it, and believe me, you'll speed up. Doing calculations just like this, 90 divided by 5.
Let's... I don't know what I'm doing wrong here.
Okay, let's go through it.
Well, 5 into 9 is 2.
1.
It's 1.
1 times
then
5.
It's 5. Then you have 4 left. And then it's 8. It's 18.
Okay. And now what is 30 times 18? And notice that we don't want to do this. We want to do this. Because this is the easier calculation. 3 times 18 I can do instantly. And then I just add the 0. Whereas if I do it this way over here, I have to do 2 lines. I have to do it like this. And I have to add these together. You see the difference? You always want to leave the single digit, even if it's got zeros, in the or in the first thing you're multiplying. I mean, I don't know how they teach you to multiply. Maybe it's not even this way. But
They just do it differently. They do it the same. It's just set up differently.
okay. So 540 is the answer. Now here, even though they asked about a combination thing, A times B, the easiest way to solve this was to solve for A and to solve for B. And then just multiply the two numbers together. Notice the difference in this problem up here. Well, this problem that we had before, where we had to solve for x minus y, but we couldn't solve for x or y. Oh, it was on that other sheet. In fact, let's go back to that other sheet. It's been 15 minutes. This one here. This problem right here, where they asked us to solve for y minus x, We were not able to do that by solving for y and then solving for x. We had to solve for exactly y minus x. Different than the problem we just did. So sometimes you have to solve for the individual variables, but frequently you don't. Let me just make that a little bigger. I have a hard time. I don't have fine-tuned control with this cursor.
That's fine. I can see it.
Okay. It's funny, I would with a mouse, but I don't with the cursor. It's like trying to write with a mouse. You ever tried to write with a mouse? If I tried to write the letters with a mouse, this is what it looks like.
Yeah, it's hard.
It's really hard. It's amazing how much harder it is than writing with a pencil, you know, where you can, it's amazingly more difficult. All right, number 10.
Okay, so it says that line M goes through A, O, and C.
It bisects it. You know what that means?
It goes through it?
It cuts it in half. So
Okay.
this angle is equal to this angle.
Angle. Okay.
That's what bisect.
And then line L bisects A, O, and B.
Okay, so this angle is equal to that angle.
What is the measure of D, O, and E?
So this thing right here.
Well, you need to calculate the two angles and put them together.
A couple ways to do this problem. Let's proceed with the way you just said.
Well, you don't really know. I mean, you know that
We do know something. We do know something about these two angles. What do we know about those two angles?
They're equal.
They are supplementary. They add to 180 degrees. So angle AOC plus angle AOB equal 180.
Well, wait a second. A, O, D, A, O, and C. Oh, I get it.
Because they're linear. In other words, because
Yeah.
BC is a straight line.
Yeah, it looks confusing.
Okay. So now we know that this angle here, in other words, they want to know what DOE is. So we have to figure out what DOA is and add it to AOE.
Uh-huh.
So DOA, we don't know what that is, but we know it's what? Half.
It's half of DOE.
Well, DOA is half of AOB.
B.
In other words, angle DOA equals 1/2 of AOB.
Uh-huh.
Okay? And angle, the other one we're concerned with is AOE. What do we know about that?
That it's half AOC.
Okay. So now put these two together. I can add these two equations. So now their question is, what is this angle? DOA plus angle AOE. Well, it's 1/2. I can factor that half out, and I get angle AOB plus angle AOC. You with me?
Yep.
And what is this here equal to? From this line right there?
180.
So what's half of 180?
90.
And that fits with the picture. That looks like a 90-degree angle. In other words, if we did not know how to solve this and we had to guess, this is something you would definitely want to guess on because,
I mean, I wanted to say 90.
well,
But
the
then I
problem with that is we just saw that other problem that was drawn so out of whack.
Yeah, exactly.
In other words, the problem where they had, they weren't even close.
Yeah, exactly.
Well, whatever. So you can't assume that it's drawn to scale.
Uh-huh.
But if you were running out of time and you had, say, check mark, say you came across this and you didn't know how to do it, so you put a little check mark, you're going to come back to it or something, or you can't do that, you have to make a guess. Well, you're certainly going to guess what you see. And what that really looks like is a 90-degree angle.
Yeah.
All right, so that's it for lines and angles. Let's go to circles. We've done all of lines and angles. We've done all of triangles. I didn't mean circles, I meant quadrilaterals. Circles are after that. Yeah. Apologize, blurry hand again. Hold on. Toughest part of online tutoring is getting my two windows to fit the screen.
Yeah.
If the length of a rectangle is 4 times its width and its area is 144, what is its perimeter? We'll call this the length. We'll call this the width. I've drawn it approximately to scale, where the length is about 4 times the width. First of all, what's the formula for perimeter?
Oh, it's all the sides.
So it's 2L
plus
plus
2W.
Okay. So what do we know? What two things do we know?
We know that L is 4 times bigger. And we know that L times W is 144.
There's our two equations right there. From those two equations, we can solve for L, and then we'll have W solved for, and then we can solve for 2L plus 2W. So what's the best way to solve these two equations?
Well, if you're going to solve for L, you have to have W on its own.
Well, okay. So tell me how, there's two methods usually that are taught. In the United States, they teach two very specific methods to solving two simultaneous equations. One is called substitution, the other is called elimination. If one of the equations is already fully defined, like this one is, L is fully defined, it's equal to 4W, then I think substitution makes the most sense. So let's go ahead and substitute into the second equation 4W instead of L. So the second equation becomes 4W times W equals 144. Let's solve that. What's 4W times W?
4W squared.
What's the next step?
100. I want to say you should just say 144 divided by 4.
Okay, which is 36.
And then W is 6.
Okay, which makes L what?
24.
Which makes the perimeter what? Notice that it's easier to add W to L and multiply by 2 than it is to multiply that by 2, multiply this by 2, and add the two numbers together. You see why? Because 6 and 24 is a perfect 30.
Yeah. Yeah, I just said 48 plus 12 in my head.
Okay,
And it's
good.
60.
Yeah, okay. So 60 is the perimeter.
Uh-huh.
Now, when you're doing the math, dividing 144 by 4, it's kind of helpful to have in your thought process the fact that whatever that answer is, it's going to be a perfect square, because we know we're going to have to take the square root of it.
Uh-huh.
So you don't necessarily have to do this that way. I mean, you might get started, and as soon as you get to 3, you know the next number's got to be 6, because the only perfect square is 36. Now, I suppose it wouldn't have to be a perfect square, but if it wasn't, the answer would get really complicated. In other words, if this was W squared equals 34, now W is the square root of 34, which makes L really complicated, and you know they're not going to put that level of complication on the problem. So the moment you get to W squared equals 144 divided by 4, you know that this number is almost certainly going to be a perfect square number, which it was, 36.
I mean, normally you would also have some answer choices.
I'm sorry, what?
See, on this question, there's no answer choices.
Oh, okay, that must be unique to GRE.
Yeah, because in the GMAT, they always have answer choices, so you would be able to see if it has to be a...
Well, I tell you what, let's skip those kind of problems then. Yeah, let's not do the ones where we don't have a multiple choice.
Okay, what is the area of DEC?
Right there.
Well, if I was to just look at it and think that it was drawn correctly, all the sides looks to be equal.
Okay. Well, it's a square. They tell you it's a square, so we know that it's a 2 by 2 by 2 square.
There.
So the question is, it's the area of that part right there.
Uh-huh.
What's the area of the square? Before you go into trying to solve the dimensions, which would really take a long time. In other words, if we try to solve this by going down and figuring out this altitude, actually that works pretty good. It's not that hard to do it that way. But there's a little quicker way to do this problem. Well, let's do it that way. That's not that hard a way. What's that measurement right there?
I want to say 1.
Exactly. In other words, when the two diagonals bisect, when the two diagonals of a square cross one another, they bisect each other. This is equal to this, and this is equal to that, and the two diagonals were equal to one another, so all 4 of those pieces are equal to one another, which means all 4 areas are equal to one another. But it definitely means that it's 1 from there to there. So if that's 1, what's the area of that lower triangle?
Half.
Area of a triangle is 1/2 base times height.
Height.
What's the base?
Base is 2.
Height is,
1. Oh, the answer is 1.
Okay. So it was pretty easy to do by figuring out this height. But there's even an easier way to do this. What's the area of the whole square?
4.
How many of those equal triangles are there?
4.
So each one must be 1. What is the perimeter? Let's see, questions 2 and 3 apply to this. So now we need the perimeter of DEC, that same triangle. So now we are going to have to do a little more geometry.
Well, you have one side, and that's 2.
Okay. So what's this measurement right here? Hi. Hi.
Half?
In order to get this measurement for x, we still have to drop that altitude.
Yeah, which is 1.
What is this side over here?
1.
So 1, 1, what is x? What kind of triangle is that right there? What's this angle?
It's the isosceles.
Well, it's a right triangle. When I said what kind of triangle, I meant the left triangle, not the whole one. But this one right here. It's also isosceles.
It's 45, 45,
Okay,
90.
that's the key. It's knowing that's 45, which makes x what?
Root was it's the 2 under the
It's root 2.
root 2.
Let's review those two triangles because these are super important to remember.
Yeah, I know what they look like. I just don't know how to say it.
Well,
Words you
I
guys
call them my unit triangles because I make the side opposite the smallest angle 1. So in this case, that's 1, that's 1, that's square root of 2. You want to memorize this. You don't want to have to use the Pythagorean theorem to calculate that hypotenuse is square root of 2.
No, I always say that it's x to square root 2, and the other one is,
So the only thing you're doing is adding an x, which is perfectly fine.
yeah, and then the other one is x square root 3 2x.
Okay. The only difference is I leave out the x and assume that you know that any multiple of this would be the same ratios.
Yeah.
But I can't emphasize enough how important it is for you to have these memorized so that when you get a problem like this, you instantly know this is square root of 2. Because it saves about 15 seconds, maybe 20 seconds of having to. You can use the Pythagorean theorem to figure it out, but you might make a mistake doing that, or it just takes additional time. So, what is the perimeter?
2 square root 2.
The perimeter is going to be this plus that, right? We look at our answers. I didn't have them displayed. What is square root of 2 plus square root of 2 plus 2?
2 square root 2.
Well, it's 2 plus 2 root 2. In other words, if I have just 2, in other words, this square root of 2 and this square root of 2 gives me 2 square roots of 2. Then I still have to add the 2. I can't add it directly because this is irrational and 2 is rational. So the best I can do, the best answer I can give is that right there. That is a much better answer than a decimal answer.
Yeah.
more accurate. A decimal answer is always going to be rounded off. But the most accurate answer, the only way to give it is like this, 2 plus 2 root 2. It can't be combined further. If the angles of a 5-sided polygon are in the ratio of 2 to 3 to 3 to 5 to 5, what is the measure of the smallest angle?
Then you wanna do the back side.
I can draw a picture, but on some of these polygons, like if it was a 9-sided polygon, it would be a lot of time to draw a picture of it. So it's really better if you learn the math of a 5-sided polygon. What's the first thing we need to know about a 5-sided polygon? What are the sum of the angles?
Oh, this is the one I can't remember.
Okay, let me give you some help as to how to remember it. What is the sum of the angles of a triangle?
180.
How about a quadrilateral?
360, sorry.
Okay. Notice that I can divide the quadrilateral into half. Two triangles, 180 plus 180. Well, if I have a 5-sided figure, I can divide that into 3 triangles. By going from one vertex, creating triangles, going to whatever vertex to create that other triangle. So what's the sum of those?
540.
And the general formula is the number of sides minus 2 times 180. Notice that that works for a triangle, 3 minus 2 times 180. Works for a square, 4 minus 2 times 180. And works for a 5-sided, 5 minus 2 times 180. But if you have difficulty, or sometimes it's n, this is what our school system tends to use, is n, the number of sides minus 2 times 180. If you cannot remember that formula, always know you can do it by this other method. Divide the figure into triangles and add up the triangles. So, if we know that they have to be 540, what's the next best step?
Well, I mean, I would back solve it.
That's what I would do. And what's the measure of the smallest angle? So what are we going to start with?
20.
Actually, there's a good argument as to why you should start with 40. And I don't know why I didn't see it for your other question, because it was the same exact argument. You were correct before, and I think 40 is correct here. And I'll tell you why. If we start with 20 and it proves to not be correct, which one do we do next?
Then you do B, but...
And if that's not correct, which one? And then C, then D, then E. We potentially might have to do 5 of them if we start with 20.
I always do B and D.
Good. So let's start with 40.
Mm-hmm.
So the smallest is 40. What's this one here? In other words, the 2 is equal to the 40. The 3 is going to be what? This is 60. What's the 5 equal to?
100.
Add these together. We got 100, 100, 100, 100. We get 360. It's not big enough. It's got to be 540. Which direction we need to go?
We need to go down. So I would take D, which is E.
No, hold on. We need these to add to 540. Right now they add to 360. So we need to go up.
Oh, well, when I say down, I mean to
Ah,
see.
okay. I'm sorry. Yeah, I
Oh,
get it.
no worries.
I get it.
It's
I was talking the number size, and you were talking the
letters.
direction on the letter. Okay,
Yeah,
so
sorry.
80. No problem. Well, what can we tell instantly if I let this be 80? What's the sum all I'm going to be?
Double.
720. That's not right either. What's
So
the
the answer
answer?
must be 60.
And we're done. We don't want to have to do the math.
Uh,
Notice that the math might not be all that easy on 60. It's good that we know that 60 is the answer because it could be a little more complicated. No, I guess it's easy. This is 90. This is 90. This is 150. This is 150. So that's 480, and 60 is 540. But what I was trying to get at, that it might not, this might not end up being a nice round number like that, always.
uh-huh.
So it might be difficult to actually do the math on that one, but we don't need to. Once you know that 40 is too low and 80 is too high, you're done. Now notice that if we'd have started with 20, we would have had to test 3 different scenarios. We would have had to test 20, we would have had to test 40, and then we would have still had to test 60 because we wouldn't know 60 was correct. We might, 80 might be the right answer. So
So I
that's the advantage of
think
doing B, and D. B and D pretty much guarantees you only have to test 2 cases.
uh-huh.
Okay.
By the way, I should probably tell you, even though we're doing 2 hours, I have to leave at like 7, like a quarter to 7,
That's fine.
because
That's
school starts tomorrow, so we have already, group meetings have already started,
okay.
apparently.
Yeah, no problem. So at about 6:30, we'll go back and do a little bit more of those data sufficiencies. How's that sound?
Okay.
We'll
That sounds great.
do those for 15 minutes. How
Uh-huh.
about number 5 here?
In the figures below, the area of the rectangle ABCD is 100. What is the area of rectangle EFGH? That's a really weird question.
Okay, so if you don't know where to begin, begin with what you do know. They're telling you the area of this rectangle is 100. What equation can I write that represents that statement?
X plus 4 times x plus 1 equals 100.
Okay.
And then
Now I can proceed in 2 ways. I can actually solve that for x. That's a quadratic. Well, I might be able to solve it for x. What should I do next?
well, I would probably, if it was me, I would have solved for x and then put x in.
Go ahead and multiply these 2 together. What do you get?
Well, it's x squared plus 4.
Okay. When you multiply binomials together,
It's x squared. It's, well, if it was a plus b squared, it would be a squared plus b squared plus 2ab.
okay, but this
So
isn't really a plus b. So the way we're going to multiply these 2 binomials together is every term by every term. So
Yeah,
we've
that's
already
what
done this one.
yeah, and then I said, oh, so then I said, oh, I just did it in a different row than
That's
you.
all right. Doesn't matter. But either way, you end up getting this.
Uh-huh. Which is 5x plus 4 is equal to 100. So x squared. Well, can you just factor it?
You can. How would I solve this problem? There's going to be a shortcut, but If I didn't have this shortcut, what would I do next to solve this? How do I solve that quadratic?
Well, you could say x squared plus 5x is equal to 96.
Okay, but you don't solve quadratic. The way you solve quadratics is by putting everything on one side and 0 on the other. So for me to solve this, I have to do this.
So it's minus 104.
It's actually minus 96. And now I can factor this. Well, once I factor it, I solve for x. It's not easy to factor.
No, because 96 is a really big number.
We need two factors of 96 that equal 5, that subtract to the number 5. Let's see, what is that? 16 and 6. It's also 8 and 8. See, 8 goes into this 12 times. That doesn't subtract to 5. This doesn't factor well. Good. Okay, I like this problem because it's extra hard. In other words, the only way I can really solve this would be to use the quadratic formula, right? If a quadratic does not factor perfectly into integers, then the way you solve it is to use the quadratic formula. But,
I don't think I've ever seen that one.
well, you won't, because we don't need the quadratic formula here. For the moment, let's leave it like this. In fact, let's go ahead and leave it like this. Now let's look at the second rectangle. What can I say about the second rectangle? What is the area of the second rectangle equal to? What does that multiply out to?
What it multiplies out to?
You'll see where we're going here.
So x squared plus 3x.
Keep going.
Plus 2x plus 6.
Which is x squared plus 5x plus 6. So in one case, we had x squared plus 5x plus 4 is equal to 100. So what is x squared plus 5x plus 6 equal to?
A little more than 100? 102?
102. Precisely 2 more. Because the only difference between these two is the 6 versus the 4. So if this quantity is equal 100, in other words, the x squared and the 5x are common to both.
Yeah.
So these two areas differ by only 2. This one is exactly 2 bigger than this one. So it has to be 102. So notice that we were able to answer the question without solving for x. We never did solve for x. And that's a good thing because it wasn't easy to solve for. That quadratic was difficult to factor. It was difficult to factor 96 into two numbers that subtracted to 5. So this kind of required a little bit of thinking outside the box, where you kind of just have to distribute both of them and see if you can see any similarities between the two. I didn't really need to write that step there. I really probably should have stopped right there and then immediately looked at the other rectangle, multiplying it out, getting this. Then I can make the leap that if this is equal to 100, this is equal to 102. All right. So let's see, we got through 5. Let me make a note of that. On quadrilaterals. And let's go back to this much more easier on the eyes test. So I need to pull up the next page. More geometry. There's a lot of geometry on these. I think there's maybe more geometry than any other thing. Although there's a lot of algebra too. And incidentally, these sections we've been going over that on circles and triangles and squares, they have algebra also, polynomials. And we'll want to go over those after we're done with geometry, I suspect. Even though you said you were weaker in geometry, I think it might be useful to review algebra on its own subject material also.
Uh-huh.
Okay, here we have what kind of question. First thing you always want to tell yourself, is this a problem solving or is it a data sufficiency?
Well, you know it's a data sufficiency because there's only 2.
Right. But I can't tell you how many times I've come across a problem and started reading it and trying to answer it before I even recognize, oh, this is a data sufficiency. You can't answer it from the stem. I've wasted a lot of seconds trying to do that.
What does the arithmetic mean?
Arithmetic mean, you know what that means, the average.
The average.
What's the average of A plus B, or what's the average of A, B, and C?
A, B, and C.
What is the average mathematically? How would I write it?
A plus B plus C divided by 3.
Okay.
The median of A and B is 5.
Actually, median,
Yeah, so the median of A and B is 5. So
right, and that does not mean mean. It's immaterial here, but actually it's not immaterial. It's important. That doesn't mean anything to us. The median of A and B is 5. The median is the most common. You have the median, you have the mean, the median, and the mode. Excuse me, the median is the most
common, right?
Right, right. The median is the middle one.
Yeah, so like if it was like
1, 2, 7, the median is 2. The average, the mean, is 3 1/3, and there is no mode. I mean, they're all equally common. Okay, so we know the meaning of the words. Okay, good.
Yeah.
So let's take the easier one to work with, number 2. Let's start with 2. Does this help at all?
Well, it eliminates the...
Does this allow us to answer this?
No.
Fact that C is 9. No, it doesn't say anything about A or B. So 2 alone, no. About 1 alone.
No.
Okay. About both together.
Well, the fact that you know that the median is is 5 still doesn't say anything about A and B.
Kind of does. It says they have to add to 10. In other words, if I gave you 2 numbers and I said, what's the median of those 2 numbers? You would add them together, take half of it, and come up with 5.
But that would be the mean, not the median.
But when you have 2 numbers and only 2 numbers, the mean and the median are the same thing.
Oh, yeah, sure.
Right? I mean, I didn't realize that until just now. That when you only have 2 numbers, the mean and the median, I believe, are the same thing. I think
Well, I guess you
regardless,
can get an average then, because then the top would be 19
right,
and divided by 3. I mean, it wouldn't be an equal number, but
that's okay. But you can figure out that A plus B have to add to 10 from
and
statement number 1.
therefore the answer is C.
Yes. And no, the answer is C. Both of them together. Isn't C both together can answer it?
That's what I said. The answer
Oh,
is
okay. And then D is each one individually, and E
E and
is
none.
neither. Yeah, okay.
Yeah.
Okay. Let's go to another data sufficiency and geometry. Perfect. I want to know the sum of C plus D.
Okay, well, if you know that B plus F is 80.
This is a good question because it's going to allow me to help you solve this graphically.
That doesn't make any sense to me.
Let's start with the easy one, which is
Oh, I'm
number...
looking at the wrong B.
No, let's start with number 2. And the only reason that's the easy one, it's not clear which is the easier one. They both look exactly equally difficult. But 2 actually is quite a bit easier. Notice that if A plus B is 110, what's this angle right here where my hand is?
It's, sorry, 70.
Okay, and if that's 70, what's this angle?
70.
And if that's 70, what is C plus D?
110.
Okay, so 2 is a yes. We can answer what C plus D is based on 2 alone.
Mm-hmm.
Now the question is now we have to look at B plus F alone is 80. Well, I could spend all day trying to figure out the relationships here, but there's a real easy way to show you that this cannot tell you what C plus D is.
Can you just put them together, like draw them together?
Imagine changing the slope on that line right there and this line right here.
Mm-hmm.
That's going to change B plus F, but it's not going to affect C plus D at all. You see what I mean? Make this slope different. Make this slope different. Doesn't change C, D, does not change this little triangle at all. So B and F can't have anything to do with C plus D.
So therefore, B is the right answer.
Yes. In other words, 2 alone can answer what C plus D are. But B plus F cannot, and merely I know that because I can graphically change this diagram, changing B and F without changing this triangle here.
Yeah.
And that's what I wanted to point out. Because a lot of these problems, the best way to solve it is graphically, not algebraically. It's to graphically alter the image in your head so that you can see that that relationship doesn't, in other words, the relationship between B and F cannot force the relationship of C and D because I can change these. All right, so we got through 19 on our test. And you want to do one more? You got time for one more?
That'll be fine, yeah. One more is fine.
Okay, let's do 20. It's a straight inequality, which is good because we haven't talked any about inequalities. How do we solve this inequality?
Minus 2x is larger than minus 5.
You can look if you look at the answers, every one of them solves for x, right?
Yeah, so I would say that you would have to put x, you have to put minus 2 on the other side.
Got to divide both sides by minus 2. When you say put minus 2 on the other side, it's not being added or subtracted, it's multiplying the x. So I have to divide both sides by minus 2.
Yeah,
and what does that force me to do with that right there?
You have to turn it around.
Correct. So what's the answer?
That x is smaller than 5 by 2.
These two cancel one another out, so I just have 5 over 2. So it's A. So the only thing you really need to know about inequalities is that when you divide or multiply by a negative number, you turn that thing in the other direction. But notice you still divide by minus 2. In other words, you still divide a minus 5 by minus 2 to come up with a positive 5 halves.
Yeah, I'm sorry if I'm using the wrong words. It's just,
Oh, don't apologize. And in fact, you're actually doing quite well. We really have had very little problem with word translation, which I'm surprised at.
When I write it on my paper, you know, I know what it's supposed to look like, but I can't explain it.
And we haven't really come across a lot of problems where you need to know what supplementary or complementary means. Usually, as long as you know they have to add to 180, that's what's important. It's not important that you know the word supplementary. Although I can't guarantee that there won't be questions that say, you know, X is supplementary to Y, so it might be helpful to know some of these words. But words like mean, median, and mode, it is important for you to know those.
Yeah, but I knew
standard deviation.
What I studied.
Yeah. The one thing that I learned for the first time tonight is that the median and the mean are the same if you only have two numbers.
Yeah, well, I guess that makes sense because when you have to find the median, when you have like an equal
number, you just take the middle number.
Take the average of the two middle ones.
Right, exactly.
So that makes sense.
It does, yes.
Okay.
Okay.
Well,
well,
thank you so much.
Yeah, and I'll only charge you for 1 3/4 hours.
Oh, that's okay.
Tonight, and let's see, you sent payment for 1 hour, right? Am I off on my bookkeeping?
I forgot to, I don't know what happened, but I forgot to pay you for the last lesson, so I sent you payment for 1 hour from the last lesson.
Okay. I have all the numbers, so it's easy for me to reconcile, but...
That's great. I mean, I shouldn't be missing anything when I'm going to go in and just send you the money right away.
Yeah, well, you only have to pay 3/4 of 32, which is 24, for the second session today. Okay, sounds good. Well, good luck with your studies.
Oh, thank you. Well, I mean, it's getting a little tough now that school's